Welcome, Tigers. Today we're going to be working with slope and y-intercept. Here are our I can statements for the day. I can identify the slope and y-intercept from an equation in the form y equals mx plus b. Also, I can identify the y-intercept from the graph of a line. And last but not least, I can explain the y-intercept is always an ordered pair in the form 0, comma, y, and is the value of b and the value of b in the equation y is equal to mx plus b. Because sometimes we talk about the y-intercept just as one number, but this I can is telling us that we also recognize it as an ordered pair. An equation is in slope-intercept form when it's in the following form: y equals mx plus b, where m is the slope and b is the y-intercept. So far, we have concentrated a lot on the slope. In the first target, we talked about y equal kx, where k was the slope because it always went through the origin. Then we kind of did a shift to m is the slope, and now we're going to talk about b, which is the y-intercept. Find the slope and the y-intercept. When an equation is in standard form means ax plus by equals c, or the constant. We can't just pull out the slope. We have to first change it into slope-intercept form, and then we can identify the slope and the y-intercept. So that's what we're doing on this first example. In order to put the equation in slope-intercept form, it has to be equal to y. So this is our goal. We want it to look like y equals mx plus b. So to get it there, we want to think about always isolating the variable of y. So to get y by itself, we have to get rid of negative 3x because it's on the same side of the equation. So to get rid of negative 3x, we're going to add 3x on both sides. Notice that I'm writing the plus 3x kind of away from the negative 7 because I can't combine a negative 7 and a positive 3x. That's really important. Once again, I can't combine negative 7 and positive 3x because they aren't like terms. That's going to go away. All that's left on the left is y. I keep my equal signs lined up. And then I'm going to go ahead and move the 3x up front or right next to the equal sign because I know that the equation calls for mx to be up front and then the constant or y-intercept to be second. Once the equation's in slope-intercept form, then I can identify the slope and I can identify the y-intercept. So to do that, it might be helpful, like you can rewrite the equation underneath like this: y is equal to mx plus b, where m, or the slope, is 3, and b is negative 7, or the y-intercept. So what does that mean? M is our rate of change. B tells us the place that the graph crosses the y-axis. And just kind of in everyday terms, I always think of B being the beginning because we will get to a point where we are going to graph these equations. Number two is also in standard form. So when I look at the equation, I can't pull out the y-intercept and the slope. And so in order to do that, we're going to change it into slope-intercept form by, once again, making sure that the equation is equal to y. So to get 5x to go away, we have to subtract 5x on both sides of the equation. And I end up with a negative 2y equals negative 5x minus 10. Well, we're not trying to solve for negative 2y, we're trying to solve for y. So I'm going to divide both sides of the equation by negative 2. Y is equal then to 5 halves x, because a negative over a negative, well, that's just going to make a positive. But then I have negative 10 divided by negative 2, which gives me a positive 5. Once the equation is in slope-intercept form, then I can easily identify m and b, or b, which is the y-intercept, and m, which is the slope. So that's how we're going to find the slope and y-intercept from an equation. Then we also will be given graphs. And so the same thing, I have to identify the slope and the y-intercept. So thinking back to when we talked direct variation, notice where this graph goes through. It goes right through the origin. So the slope of this line, the y-intercept, or the place that the graph crosses the y-axis, is 0. We can also say that that is 0, 0 as an ordered pair. So really the answer can be, you could say it crosses the y-axis at 0, or if just to kind of as an extension, we also identify that as an ordered pair. So we know that it crosses the y-axis at 0, but that ordered pair is 0, 0. The slope, well, in order to find the slope, we've learned about this before, we have to identify a point on the line and a second point on the line, and then just kind of see if that pattern repeats itself. The slope we know is rise over run. And I notice that this line is positive. In other words, the line is going up. So if I rise 1 and I run 1, and that process repeats itself. Please make sure that you check, because sometimes it might look like it goes through that point, but if you check and go up 1 more, then maybe it's off a little bit. So it really is important for you to continue to count that process. So whoops, I need to get my orange back out. So we rise 1 and we run 1, much better known as just 1 whole. So the slope can be a point on the line and or an ordered pair. The slope is always a rise over run. The slope is it will never be an ordered pair. It's going to either be an integer or a fraction. Find the slope and the y-intercept. So step 1, I'm going to always start with b, which b is the y-intercept. We can also call b the beginning, because it doesn't mean that that's the place that the graph itself starts, but it means it's a good beginning place for us. So our eyes need to go to the y-axis. So here we are at the y-axis, and I notice that this line goes through the y-intercept here at 4. So we can say that the y-intercept is 4. If I were to write that as an ordered pair is always x and then y, so that would be 0 for the x, meaning from the origin I didn't move at all, and then I went up 4, or positive 4 for the y-intercept. The slope, I notice right away is negative because the line is going down, so I'm just going to go ahead and put that negative there so I don't forget. It's very important to identify whether it's a negative or a positive intercept. And then my eyes just kind of go down from the y-intercept. I'm going down the line, and then I notice that the line doesn't cross an intercept until it gets to this point right here, because it has to be exactly what I mean by intercept is a place that an x line and a y line meet. So the slope would be down 1, 2, 3, and over 1, 2, 3, 4, otherwise known as down 3 and then right 4. We don't want to make that a negative negative, just in other words, a negative just goes with one or the other because we want it to be a negative slope. Another consideration, because I noticed that there's another point on this line, just to really make sure it's negative 3/4, I noticed this point right here. So I could also, from the y-intercept, I could have gone up 1, 2, 3, or positive 3, and then back 1, 2, 3, 4. Well, isn't that interesting, because that's still negative 3/4. We really have to kind of start to recognize that the negative can go with either the numerator or the denominator, but not with both. And so we went up, which is positive, and back, which is negative. So we identified the y-intercept as 4, or as an ordered pair, 0, 4, and then the y-intercept as negative 3/4. And moving right along, here's another graph for us. So we want to first identify where the graph crosses the y-axis. I notice it crosses right here, so that's going to be at negative 3. As an ordered pair, we would write it as 0, negative 3, and then we need to count to identify the slope. So in order to identify the slope, I need at least 2 points on the line. It's going to cross here, and it looks like it crosses there. So that's going to give me a rise of 2, starting at the y-intercept. I rise 2, and I run. So we went up 2, and then I just run 1. And then that process repeats itself. So once again, I went up from here, up 1, up 2, over 1. So rise 2 and run 1. Both of those are positive, and that should make sense because you'll also recognize that the line is going up, which tells us that it is a positive slope. So why don't you pause the video and see if you can recognize this one on your own. Once again, you're picking out the y-intercept. It looks like it's on the graph, but just write it as the point and then the ordered pair, and then also the slope. When you're finished, then start up the video again. So here we are, our y-intercept, or the place the graph crosses the y-axis, is at 5. As an ordered pair, we say 0, 5. Wasn't it nice of them to write that one on here for us? But then the slope, I notice right away, is the line going up or is the line going down? Well, we know that it's going down, and so I still have to identify a point on the line. Also, look at this one. See how it's already identified for us? It tells us that it crossed the x-axis at 2, 0. So start at your y-axis. It's going down, so we're going to count down first. 1, 2, 3, 4, 5. So down 5, that's going to be negative. And then when I go right, that's going to be positive. So from this point, 1, 2, so our slope is negative 5 halves. And just leave it as an improper fraction. There's no reason to change that into negative 2.5. But here's something to consider, that let's say I started here, then I would have gone down 1, 2, and then a half, and then over 1. See how that works? But if we had to graph that on our own, it's a lot easier just to go down 5 and right 2 rather than down 2.5 over 1. So you do want to leave it as an improper fraction. An improper fraction that is simplified. So let's say that I didn't recognize 2, 0, but that I recognized, where would we be here? Let me follow the points. Looks like it's going to be off the graph. Wait, 1, 2, 1. Actually, it's kind of off a little bit, but now that I count, so here's another thought. Let's say we didn't recognize the 2, 0, but we recognize this point right here. So from here, from our original y-intercept, we would have counted down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then over 1, 2, 3, 4. So negative 10 fourths isn't a bad answer, it's just not the simplified answer. So we want to make sure that we go with the simplified answer of negative 5 halves, which we had up front. But let's say we didn't recognize that all along, we would want to still simplify our final answer. Alrighty, we've got another example before kind of a special case. Step 1, find the y-intercept. I've got a negative 2. If that was an ordered pair, it's always going to be 0 as the x, and then the y-intercept, you'll notice, is the second coordinate because it's the point on the y-axis. As far as the slope is concerned, I notice that it's a positive slope because it's going up. Here's another point on the line, so from my starting point, I would go up 1, 2, and over 1, and repeat that process. So up 2 and then run 1. Better answer though, just simplified, would be a positive 2. On this graph, we actually have 2 lines, and you're going to start to see more of these. So identify when you have y is equal to, then it means that your line, let's look at the blue line, y is equal to 2. So if you can't see that on your PowerPoint, go ahead and write it. It just says y is equal to, actually negative 2, right? So y is equal to negative 2. So we're referring to this line right here. And so if it was, let's say that the equation, because we know about y is equal to mx plus v. So one thing that I know, I'm just going to kind of substitute in here, that the slope of a horizontal line is 0. So I'm just going to fill that in for m because we know that's the slope. We know that anytime, because I could stand on here, but I'm not doing anything. I'm not going up or I'm not going down. So it's y is equal to 0x. Well, the place that the graph crosses the y-axis is right here at negative 2. So you can easily see how that simplifies down to y equals negative 2. Because if it's 0x, I just don't need that 0 at all. Also something to consider, remember when we used a table of values? If this tells me that y is equal to negative 2, that means that y has to be negative 2 every single time. So you can just put some numbers in there, and then maybe we put our own numbers in for x, because all it's telling us is that y has to be negative 2 each time. So if I put in negative 1, negative 2, then on the line I would be at, starting here at the origin, I would go left negative 1 and then down negative 2. And then let's say I put 0 in here. So 0, negative 2, or 1, negative 2. So my point in mentioning that is that that's always something you can refer back to also. If you can't remember, okay, y is equal to negative 2. Is that the one that's perfectly horizontal, or is that the one that's perfectly vertical? Well, the answer is it's the one that's perfectly horizontal, and that tells us this table of values helps us to kind of bring that point home. So if we're talking about the slope, which is what we need to find here, first of all, let's start with our B, or beginning. So the y-intercept is the place that the graph crosses the y-axis, so that would be a -2. It crosses the y-axis at -2, and then you already know that the slope is 0 because we've learned that a line that's horizontal, the slope would be 0. But then how do we handle this x is equal to 3? That also is an equation. I don't even see a y in that. Well, the reason there isn't a y is because you may have guessed it, this line does not cross the y-axis. Here's our y-axis, and it's never going to cross the y-axis because it's parallel with the y-axis. So what is the slope in the y-intercept? Well, the y-intercept doesn't exist, so you might say none or doesn't exist. And then the slope, I know you already know this answer. What is the slope of a line that is perfectly vertical? Is it 0? No, that's when it's perfectly horizontal. The slope of x then would be undefined. So when the equation looks like just x is equal to something, then it's always going to be undefined. I hope you enjoyed your lesson on finding slope from a graph, as well as finding slope from given the equation.